on at some point. Okay.
Yay.
Okay, so for some reason, there's only one little one of those weird true false questions at the beginning of this quiz instead of two, but.
Oh, sorry. Let me get there to the quiz.
Wait, man.
Okay. I'm there.
31 questions on this bad boy.
Yeah.
Woo! See, I don't know. I was hoping maybe it would be the same as the review sheet because it says it would be duplicated.
The first question is directly from the book.
The following variables is our categorization.
All right, so if we're keeping with our order, you're up first.
Okay, I'm first. Okay. Which of the following variables are categorical? So that's everything without a number. So that would just be B.
Yes.
I think so too.
Okay.
All right. The mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test, and the mean of their scores was 112. Which of the following statements is / are true? 100 is the parameter, 112 is the parameter, statistic, and 112 is the statistic. Okay, so I believe it's 112 is the statistic and 100 is the parameter.
I agree.
Yeah.
I actually just reread that this morning while I was preparing for it. So
I like Rotham City. I think that's funny.
Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values and another has extremely high property values. Property taxes are usually roughly proportional to the property values. What type of sample should we collect to gauge the residents' responses to a proposed increase in property taxes?
So this one was weird to me, because like it asks should, and like, you know, a simple random sample is kind of the best one, isn't it?
Yeah, I was thinking.
I mean, but stratified, it's like it's kind of set up that stratified is kind of the obvious choice, though, right?
Where they're
Well, when you do stratified, you section it out into strata, and then you do a simple random sample. So
since they are kind of categorized.
Yeah.
Go stratified.
As I said, that's a weird question because I really think it could go either way.
Yeah. Yeah. Okay. Question 5. When designed experiments are conducted in a public school system, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in the selected classes. Which type of sampling scheme is implemented? I put cluster, because cluster is just randomly selected, and they say, okay, let's say 4th grade students in that district.
Oh, yeah, you're right.
You think?
Yeah, yeah. I mean, because well, it's certainly not stratified since they're not doing every single group,
Mm-hmm.
and it's not a random sample since they're not going over the entire school
Mm-hmm.
or the
And
school
it's not
district. Rather.
voluntary. Yeah.
Yeah.
Okay.
Sounds good to me. Cluster.
All right. Yeah, cluster. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which of the sampling mean schemes was implemented? It's a simple random sample.
I agree. Okay, me. Oh, Matt, sorry.
A special interest group is conducting a survey regarding wolves in Yellowstone. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took the list of registered Republicans and selected a simple random sample of 100 people. What type of sampling scheme was implemented? That one I would call it stratified as well.
Yep.
All right. Okay, so this one we need to pull up this Excel spreadsheet.
My computer is just really difficult with me on that. But think about it.
What's the file called again? I have them all downloaded already.
Crossroads purchases. That's a good idea. That's what I need to do. Just download them all.
Okay.
Okay. Using software.
Now, where's the other thing is the
Quantitative Descriptive Statistics Excel is the other one.
Mm-hmm.
Oh shoot, I don't have that one. Where's the fastest place to get that?
I think I emailed you that one.
Oh, you did. Hang on. Come on, computer. You are being just stupid slow. All right.
So once we get there, this is the one where we just cut and paste from the Crossroads file into the applet.
Yep.
Right.
All the information. And then it just calculates everything for us.
Correct.
Yep. So I think I answered number 8. Let me know when you guys have it, and we'll see if we did it right.
I got it.
4.771.
Uh-oh. No. For the mean, I got 542.3. Let me go in and get it open because I did this before, so let me open all my stuff up.
Apparently something was corrupted and I couldn't open the file, so I have to I'm trying again. You are taking your sweet time there, Excel.
Yeah, Becky, I just tried it again and I got the same answer, so maybe I'm doing it wrong there.
Okay, let me try it again.
Yeah. I'll double check and see what I'm doing too.
Oh, come on, you're killing me. Why are you opening it again? Okay.
Did you clear out all the stuff first, Matt?
Yeah.
Yeah. Maybe I didn't.
All right, hang on. I got it up. Let me delete these. Here, and insert that. Okay, and we're looking at the mean.
Mm-hmm.
I got
Sorry, Mike.
4.771.
What'd you get?
4.771.
Okay, that's what you got too, Matt, huh?
Yeah, that's what I got.
Okay, let me figure out what I'm doing wrong here.
You scrolled down and got all 22 lines or something? I don't know.
Yeah. Hold on, my computer's working on it. Still working on it.
Naturally.
I don't know how it takes that long. Okay, let's see. Oh, yeah, 4.77. I don't know what happened there. 4.771. What I get. So I don't know if I just wrote it down wrong when I did it.
It's okay.
Yeah,
Well, it's fixed now, so.
yeah, good.
All right, so moving on, the standard deviation is going to be 1.912 since we're rounding to third decimal.
Yep.
Mhm.
I got number 10 here. True.
Yes, I did.
I did. Right. Information. Should we just read through the information on our own?
Sure.
I'm ready with 11 whenever anybody else is.
Let's do the average real quick. Let me just get this. What did you get for 11 there, Becky?
I got 0.165, 0.165.
That's what I got too.
Yep.
All right.
Alrighty, I'm going to go ahead and take a shot in the dark here and say that number 12 is going to ask us to figure out B. All right, so first we have to figure out A, so that's 37.25. Hang on a second. Get my calculator on. We're going to 3 decimals?
Yeah.
Okay, so I got 0.526.
I got 0.681. Did I get one?
Probably not. Hang on.
Becky, what did you
Let's
get?
see
I got 2.25.
We're doing 37.25.
And then the A should be 1.
I just did it again and got 0.681.
Yep, that's what I got.
Okay, so what did you get? What did you do? Walk me through that.
So you subtract. So the mean is 38.075, and you subtract 37.25 from that, and come up with something.
0.82.
You can come up with 0.825, and then you square that to get 0.6806, which rounds to 0.861.
Okay. So you take. Sorry, one more time. 38.075, and then you
subtract 37.25 from it.
37.25. Why?
Because that's the value in the column that B's in.
Yeah. Okay.
Roberta's
X minus sample X.
Gotcha.
Or body temperature.
Yeah. Okay. I'm there. Thanks.
Yep.
Okay. Square. Got it. Okay. 13. Who's next?
Let's see here. I did the last one.
I can do it here, but I'm not sure of the answer. I've forgotten. What quantity is equal to the sum of the number in the squared deviations column? So column B that we just did. Standard
Hey guys,
deviation.
Sarah.
I didn't see the email. I'm sorry.
Oh, it's okay.
We need your help, though.
Okay, well, let me get where you guys are. All right, let me see what we got. I am coming.
You're fine.
Okay.
Variance, actually.
Which problem are we on?
The variance?
Yeah, I just
Yeah, I
just found it.
look up the
Sarah, we're on
definition
13.
You're on 13. Can you guys catch me up?
Of course.
Yeah,
Mark
absolutely.
has to go soon, so if you want to jump on 13 and then we can catch you up after he needs to go, if that's okay.
Oh, that's totally,
Oh yeah, that works too.
that's totally fine. Let's get down to 13. Hello, beast of a quiz. Okay, hold on. What is the quantity? Okay. What? I have no idea what's going on. I feel like I just came into the middle of a bad movie. Okay.
So I think Mac and I did that in a similar way. I find myself when I was doing the quiz going to the index of terms quite often. And
the variance.
If you look up variance in the terms that they use, that's the definition.
Yeah, it's variance.
Yeah.
Hold on. Make a note. Don't you just love these guys? Variance.
It's like they dropped the sample from it, right? Because it's really we've been referring to a sample variance.
Yeah. Okay. So I don't have anything on whatever problem we're working on. So we're on 14. What's the standard deviation of these temperatures?
So in our quantitative thing, it's 0.715.
0.715. Okay.
On 14.
Yeah, that's what it's the dealio.
Under certain conditions.
Okay, sorry, go ahead.
You're fine. Standard deviation can never be negative, correct? So that one should be false.
Yeah.
Correct.
Okay.
Okay.
Stupid seal.
Okay. In the same study, the researchers placed thermistors in the 3 cells near their spinal cords and brain in the extradural vein. They placed thermistors in 6 other cells in their aortas, the largest artery in the body. Finally, they placed thermistors in 4 other cells in their hepatic sinus. Results from the study are summarized in the table below. Which location resulted in the most consistent temperature measurements from one cell to another? And
so that's the smallest standard deviation, correct?
Yeah.
Yep. So the extradural.
Yeah. Yeah.
Oh, box plots, how we love you.
All right. What is the third quartile? That's 8?
Yep.
And then what percentage of the data lies between 4 hours and 8 hours? Listed as a percent and not a decimal. That's 75%, right?
50%.
Yeah.
Yeah. 0 to 2 is your 2 to 4 is your first quartile. So it's the first 25%, right? So 25% is out there. 8 to 12 is the last quartile. So that's so the box itself is 50% of the data.
Gotcha. Sorry. Thanks.
No, I figure we're doing this so that if we misunderstand something, one of us can explain it to the other ones, right?
That's perfect.
Okay. Unless it turns out our explanation's wrong, then we can all just boo at the person who told us the wrong thing. All right. Oh, P.S. I found the best way to make your notes for the test is to use a Microsoft document. and make columns. Just a side note.
Oh, that's a really good idea, because then you can just make them cumulative for all the tests, huh?
You can, and the other thing with it is you can use bold and other things to kind of make headers so that you can organize it in a semi-intelligent manner. Okay, anyways, now that I'm done with that.
Hey, I'm back.
Okay, the observation of a normally distributed population is called unusual if there's more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations about 10 p.m. Are considered a health risk for infants less than 6 months of age. The city of Rexburg reports a nitrate concentration of the city's drinking water supply between 1.59 and 2.52 parts per million, and values that are unusual. We assume blah 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 and blah blah. It is reasonable to assume it's normally distributed. Question 19. Estimate the mean of a measured nitrate concentration in Rexburg. Okay. Sometimes I think they're trying to be way too clever. So we need to solve for the U thing.
Okay. Did it tell us how to do that before and I forgot, or?
No, this is basic algebra. They're just being jerks. I'm saying that out of love, but they are being jerks. Yeah.
Okay, so is the standard deviation is
So we have to solve for U, and then so it's a gosh, how do we do these? It's just a 2 equation. We have to use 2 equations to solve for it. That's what we can do. So.
I'm not doing it. I did it when I did the thing. I got 2.055. But I've been wrong before.
All issues out. Hold on. I'm quadruple checking make sure I'm doing this right.
New message.
Okay. Oh, that's right. We can do substitution. I remember substitution now. It's my favorite. Okay. So if you use substitution, you set the mu thing equal to 2 times standard deviation 9. And then the next equation, we plug that in. So we do 2.52. Yeah, 2.5.2, because we set them both equal to mu. 2.52 minus doesn't work. I don't know what I'm doing. Oh, we said no. We said them equate to each other.
So I got U to be 2.055. Is that what you said, Becky?
Yeah.
Wait, what was it? Sorry. 2.055?
Yeah.
All right. That seems right.
I don't remember how I did that. But
I like it. Just sorry. I hate it when they do stuff like this.
Good job, Sarah, thinking of the substitution. Though once you said that, it all made sense. But up till then, I was stumped.
I do what I can. I was just running right behind you. I was like, where am I? Okay.
Mark, are you doing okay?
Yeah, I'm all right.
You need to take off?
I'm just pretty soon.
Okay.
We're almost there, buddy. We're almost.
Standard deviation, we actually found we had to find first to find you.
Uh-huh.
So 0.233 is what I've got on that next one. Is that what, on 20, is that what everyone has?
0.2325.
What?
0.2325. 0.233.
Yeah. 0.2325 and then 3 decimal places is.
Yeah. 0.233.
Yep.
Wait. It's 0.2335.
No, 0.233.
Wait, okay, pause. Follow me. Okay. 0.233. All right.
And then this next one I got D.
Yep.
B, you said?
D, 1.822 and 2.288. I just graphed that out and did the 68, 95, 97 thing.
Nice. Okay.
Or you could just add one standard deviation to the average and then find the add one and take one away.
Yeah.
That'll also give you the.
Yeah. So then it skipped my weird question that I was asking you guys about before the quiz, number 23 on the review, that skipped that on here, so that's nice.
Oh shoot. Where's the probability applet? I don't have that open.
It's at the top of the quiz, actually.
Oh, is it?
I just generally recommend keeping it on your desktop. Just save it to your desktop.
Yeah.
That's a good idea.
It cuts down on so much drama when you're like, crap, where'd you put that thing? Okay. All right.
All right, let's see. We are on
The admissions committee for most masters of business administration.
all right.
So this is the one we talked about before. I'm pretty sure the answer is 50%. And that actually, you can kind of look at it and see that, because if the required admission for Mac is 500, and it makes sense logically as well as if you do the math. 50%.
50%.
Yeah.
And did we decide that we're doing 0.500 or is it 50?
It doesn't give us here.
If you put 0.05, it shouldn't matter.
0.500?
It shouldn't matter if it's like that. They won't dock if you don't put 2 zeros behind something.
Okay.
0.50.
Oh yeah, no, because you're right, because that's the mean. You're totally on, Becky. The mean's always 50%. Okay.
Yeah.
Cases. 600, that's a fun one. Okay.
So for this, I got 0.684. Yeah. So it's the same thing, only we just put 600 instead of 500.
Okay, I got a z-score of 0.
Yeah, 684. Cool.
Wait, you got that 684.
The next one is just 0.32 or 316.
Wait, guys. I'm going back to 23. I'm sorry to be a stump in the block, but I got the probability. I got a different probability than you guys. I got 0.316.
So below 600 should be the left side of the positive z-score, correct?
Correct. You're right. Thank you. Sorry.
Huh? No worries.
You guys are totally right. I misread the question.
You're all good.
So 24.316.
Yeah. Once we move on, once everybody's ready for 25, I'm unsure on that one. I have an answer, but I'm not sure. Correct.
Oh, the 10th percentile?
Yeah.
Okay, so for that one, we want to go back to our probability applet.
I got 696.532.
So, Becky, do you understand how I was getting that?
Well, I got 696.
Here's whole number 697.
696.532 or 696.8.
7 since we're rounding to the rounding to the nearest whole number.
Okay, so then my question is that the 10th percentile or is that the 90th percentile? Because our next question.
Oh my goodness, you are correct. The 26th though is 697.
Yep, okay, I just did the same thing you just did. I'm glad that Becky caught us. Oh.
So 25 should be 380. 388. And then 26 should be 697.
Hang on a second.
Sorry, guys, I'm lost on 25 and 26. Where are we getting these numbers from?
Okay, so what you do is they're giving you the 10th percentile, so you want to go over to the lovely applet that we love so much, and you want to type in 0.1, then highlight to the left of your second, your negative z-score, but your negative z-score is negative 1.291. And so what you're going to do is you're going to plug that into your z-score formula to solve for the 10th percentile. And we just don't know x. Does that make sense? Where that's coming from?
Are we getting 388 for the 10% one?
Yes.
Cool.
Mac, did that make sense?
Yeah.
Okay.
Gosh, yeah. Thank you.
Okay, so 25 was 388 and 26 was 697, correct, team?
Yep.
First quartile is 25%, so go back to the applet, put in 0.25.
Hey, Sarah, will you walk me through that one slowly? I don't know why I don't get that, but I can't figure that out.
So your first quartile is your first 25%.
So you put in 0.25. You just put 0.25 into the applet.
And then you do the negative z-score. So the zero, negative.
I knew it was something simple.
I got
461.
461? All right.
I'm kind of flying through here. I need to get going.
You're fine. Third quartile is just going to be the opposite of, so the positive version of that z-score.
Yeah.
Okay. Okay. I got 624.
Correct.
Awesome.
For 29, I got 542.3.
Hold on. 15.
Okay. So that's that'll just be 120.54 over the square root of 15, correct?
Wait, what? Where are we at? The sample mean should just be the same mean as everything else. So the 542.3.
Yeah.
Or 29.
Oh, I'm sorry. Yeah, you're correct.
What you do is the next question, which is the standard deviation sample mean. Sorry, so 120.54 all over the square root of 15.
I got 31.123.
That's what I got.
31.123.
For number 30?
Hmm.
Okay.
What is the probability that the sample mean GMAT score for an SRS of N15 will be greater than 600? How much we love you. Let us count the ways. Okay. So use that answer from last time to divide everything and we'll be fine. 1, 2, 3, 5.
I got 0.031. Somebody double check me though.
Yep.
I got 0.032.
I got 1.853. Because we got 57.7 divided by standard deviation over square root of 15, right?
We got 600 minus 542.3 over 120.54 divided by the square root of 15.
Yeah.
0.032.
I think it's 0.03. Is it 0.031?
0.0319 is the.
Okay. 0.013. Okay.
So, Sarah, are you doing the new z-score, if you will?
Hold on. Pause. What was your guys' answer for 30?
31.123.
It's on.
Okay, so if it's 31.123, which is our standard deviation, wouldn't the probability of 31 be the 57.7 divided by 31.123? Or am I missing something?
Again? It should be 57.7 over 31.123.
Yeah, that's what I thought.
And that's your new z-score.
And then that's your new z-score, and then we're going to we're shading the right of it.
Gosh, I am sorry, guys. I am way off today. I am way off.
Good.
No.
You will have my apologies.
That's what we're all here for as a group, right, Sam?
Yeah.
To the right of it, correct?
Yeah.
Okay. Sarah, should we fill you in real quick on the
Okay.
first ones, or?
Yeah, I could just let me get this one put in. I'm just having my special ceremony of the day. So we got 0.032, correct?
Yeah.
For that one?
Yep.
Yes.
Yeah, okay. I'll scroll up to the top. Again, sorry I missed the email.
Oh, you're good. Don't worry about it. So I'm gonna go ahead and end the broadcast now. I'm gonna post this later, but I gotta get out the door.
You're good.
Thanks, Mark.